Hi everybody, welcome to today's lesson on formal fallacies. Today we will be discussing denying the antecedent. We'll first take a look at a few examples of how denying the antecedent is employed in natural language as a means of argumentation. Then we'll take a look at its propositional form. And finally, we'll take a look at a proof of its invalidity. So let's get right into it. So how is this formal fallacy employed through natural language? Our first example is a rather mundane example, but it is nonetheless useful. It starts with premise 1. If it is raining, then the ground is wet. Then we move to premise 2. It is not raining, and we conclude that therefore the ground is not wet. Now intuitively, we can pretty much tell that this is a not sound reasoning. And this is because reason and experience both tell us that the ground could be wet for other reasons. For example, somebody could have a sprinkler on, and the ground could be wet because of that. Or somebody could have done a cannonball into the pool and splashed water onto the ground, and the ground could be wet because of that. However, a lot of the times, when formal fallacies are employed through natural language, it's not so easy to tell that they are indeed invalid. For example, a theist may argue the following, P3. If there are no objective, i.e. mind-independent morals, then God does not exist. P4. There are objective, i.e. mind-independent morals. Therefore, God exists. And the last example here, a compatibilist may argue the following. P5. If naturalism and materialism are true worldviews, then free will and determinism are incompatible. P6. Naturalism and materialism are false worldviews. Therefore, free will and determinism are compatible. Now, these last two arguments seem pretty convincing, especially if we have sufficient evidence to support P4 and P6. However, they are indeed invalid. And let's move on to the propositional form to see why it is indeed an invalid argument. What is the form of this argument? How can we tell when somebody is employing this form of argumentation through natural language? If we recall each example, each one has a very, very similar form to the other. They each start with a first premise that says, if this, then that. The second premise says not this, and they conclude that not that is the case. So we have a material implication, negation of the antecedent, and the conclusion is that the consequent is not the case. Now, its propositional form is what we will use to test its validity. What we do is we take these two premises and we make a conjunction out of them, and we take the therefore symbol and turn it into implication. And we have to ask ourselves, is this expression true in every interpretation? Now, there are a number of different ways to do this. However, in this video and in this series, we will mostly use the condensed truth table method. So let's go over to Excel and fill out our truth table. What you see here is just the skeleton of the truth table. All we have to do is punch in our values, and we'll be able to tell whether or not this argument or this formal argument is indeed valid or invalid. What we're looking for here is column G, that's our main operator. As long as all of these interpretations are ones or values of true, we know that this argument is indeed valid. If not, we know that it is invalid. Since we have two propositions, we know that we will have four interpretations. That is, one in which Q is true, one in which P is true and Q is true, one in which P is true and Q is false, one in which P is false and Q is true, and one in which neither P nor Q is true. So let's copy that over to our other columns while staying consistent. Next, let's take care of our negations. The negation just returns the opposite value of what we see here. So where we see a 1, we're going to replace that with a 0. And where we see a 0, we're going to replace that with a 1. Next, let's take a look at column B. We know that material implication returns a value of false if and only if the consequent is false and the antecedent is true. We see here in the first interpretation that both the antecedent and the consequent are true, so we'll have a 1. And in the second interpretation, we have a false consequent and a true antecedent, so we'll have a true. I apologize, we'll have a false there in the second interpretation, and the last two interpretations will be vacuously true. Next, let's take a look at our conjunction. Column D. The conjunction returns a value of true if and only if both conjuncts are true. In our first interpretation, we have a 1 and a 0, so that will return a value of 0. In our second interpretation, they are both zeros, so that will return a value of 0. And in our last two interpretations, both conjuncts have a value of 1, so the conjunction operator will return a value of true. And finally, let's take a look at our main operator here. And again, let's recall that the material implication returns a value of false if and only if the consequent is false and the antecedent is true. For the main operator, we will be comparing column D, our conjunction operator, and column H, which is the negated version of Q. In our first interpretation, we have a 0 and a 0, so we'll have a vacuous truth. In our second interpretation, we have a 0 and then a 1, so we'll have another vacuous truth. However, in interpretation 3, we do see that we have a false consequence and a true antecedent, so we'll have a value of 0 there. And in our last interpretation, both are values of 1, so we'll have a 1 there. And here we have a proof as to the invalidity of this propositional form. Thanks for joining us today, guys. Until next time, may reason be with you.